Okay, for this next section, which is part 2, we're going to be talking mainly about the electromagnetic spectrum. The electromagnetic radiation, which is sometimes called EM radiation for short, is basically just a form of energy. This is where you deal with the speed of light, which is 3.0 times 10 to the 8th meters per second. And I know it's not written like that there, but it should be 10 to the 8th meters per second. Now, electromagnetic waves are made up of photons. And photons are not just a wave and not just a particle, because there was a big discrepancy about this early on when they were just discovering electromagnetic radiation. But now they realize that it's not only a wave and not only a particle, it's both. Because it has an electric field and a magnetic field that go in opposite directions. That's where they get the word electromagnetic from. Examples here, if you look at the graphic down at the bottom, you have visible light and X-rays are on there, microwaves, infrared, radio frequency, gamma ray. And you see how tiny the part that we can actually see is. The visible light is very, very, very small. Okay, and here's another picture of it, and we're looking at the two different sides, okay? If it has, the blue light is going to have high energy over here on this side, and if you look, it has a very short wavelength, 10 to the negative 2, which is 0.001, and a long frequency, 10 to the 20th power. And then if you go over here and look at the red light, it has lower energy, and it has a long wavelength and a shorter frequency. So do you see 10 to the 20th is going down, and here you go down this way. So they actually are inversely related there. Now we're going to have a definition here of wavelength, and it is abbreviated with this Greek letter called lambda. Okay, this is the distance between two corresponding points on a wave. And the units, just like we use for distance, because wavelength is length, which is distance, is measured in meters, but it's usually very, very small, so it's usually talked about in nanometers, okay, which is, again, that's written wrong. It's 10 to the negative 9th, okay. Now, the way they measure wavelength is from a similar point to another similar point on the wave. Here's the wave going like this, and if you go from crest to crest, crest is the top part, the highest part of the wave, and the trough is the lowest part of a wave, okay. If you go from crest to crest, from here to there, that's the wavelength. Or you can go from trough to trough, or you can go to from a repeating. See how it's going up here on the axis? So you can go from there to there. See if y'all can see that. From there to there. Okay? I think that's all we need to say about wavelength there. And if you look here, this is a wave cycle, this is another wave cycle. Now, how could we make the frequency higher? Because this is how many is going to pass in 1 second. You could make the frequency higher by going like this. And in that same second, more waves are going to pass. Now, frequency. This is the number of wave cycles that move through a point in space in 1 second. And this is measured in hertz, Hz. Okay? Frequency is measured in hertz. And it's the same as inverse seconds, which is 1/seconds. Now, if you look, I'm going to go back. Alright, so that's it there for frequency. Now, these are related. And they're related with this formula. C, which is the speed of light, which is a constant given to you on your star formula chart. The speed of light, which is 3 times 10 to the 8th power, is equal to wavelength times frequency. And frequency is abbreviated with the letter V. I forgot to say that on the last slide. Okay? And inversely proportional. Inversely proportional means when one goes up, the other goes down. Because they're always going to equal the speed of light. Okay, which one of these has a longer wavelength? You can just look at them and tell without even looking at the numbers, because the numbers do tell you which one's larger. But do you see how this wave is spread out? It's got a longer wavelength from this crest to this crest here. And this one's a shorter wavelength. And then which one has a higher frequency? Obviously, the green one does, because it's going to have more wave cycles per second, because there's more of them with that shorter wavelength. So do you see how here we have high wavelength and low frequency? Here we have lower wavelength and higher frequency. And this shows you one goes up, the other goes down, so they're inversely related. Okay, and this is the last slide for this section, but it doesn't really go with this section because part 3, which is the next video you have to watch, will deal with trends in the periodic table.